All right, so this is going to be P2. Okay, a reminder that the answers can be found on the Calc Chat link to the Calc book. So on the module, there's a link to the Calc Chat link for the Calc book, which is where this is from. And then if you're looking for like the chapter or whatever, this would be the pre-req chapter or chapter P. I tried to do the odds. If I do the evens, I'll go over them. But if I tried to do the odds so that you could just look them up on there. So in the section in P2, it starts with inequalities. Okay, you've got your simple inequalities where you just have a greater than or equal to, a less than or equal to, a greater than, or a less than. All right, so obviously you've got your standard rules of inequalities. If you're dividing or multiplying both sides by a negative, then it changes signs. So if I had something like 2x greater than or equal to negative 10, this stays greater than or equal to negative 5. But if I have negative 2x is greater than or equal to negative, even positive 10, and I divide by the negative, that's when my sign changes direction, okay? It also, in the direction, says to put the solution on a real number line. So you want to draw out your number line. You want to remember that greater than or equal to or less than or equal to is either a solid dot or a bracket. It's greater than or less than, then it would be an open dot or a parentheses. So if my answer is x is less than or equal to negative 5, then on my number line, I would do negative 6, negative 5, negative 4, so I know which direction my number line's going. And then less than or equal to is a solid dot pointing left or a bracket pointing left. Solid dot, bracket mean the same thing. Yep.
It doesn't matter if it's greater than or equal to or just greater than, it's still going to switch direction. Right?
Correct. Okay, and then you've got compound ones in here. So like this one has 3 parts to it. Whatever you do to the middle, you have to do to both sides. So if it was 5 is less than or equal x plus 1, which is less than 10, then when I subtract the 1 from here, I have to do it to both sides. So this would be 4 less than x, which is less than 9. And on my number line, I would have 4, 5, 6, 7, 8, 9. I'd have a bracket on 4 or a solid dot on 4, and I'd have a parentheses on 9 or an open dot on 9. So there's your compound inequalities. Whatever you do in the middle, you've got to do to both sides of your inequality. Questions on those so far? All right, then comes absolute value inequalities. So when you have absolute value, okay, they become compound without you even having to do it, without it saying that it's going to become compound. So if I have something that's like 57 where it says absolute value of x is less than 5, the rule is if the variable is less than, then your inequality becomes an and statement. And I would tack the negative version of that number to the left of my variable. The sign's going in the same direction. The absolute value comes off the x. And I continue the original statement as it is. So if when I read my statement, it is read as a less than, then it becomes an and statement. So this is actually any number in between negative 5 and 5, or x is greater than negative 5 and less than 5. Which obviously should make sense, right? Because any number between negative 5 and 5 would work in this inequality. If I plug in negative 4, absolute value of negative 4 is less than 5. If I plug in positive 4, absolute value of positive 4 is still less than 5. So if it's read as less than, it's an and statement. And the reverse of that is if it's read as if it's read as greater. So greater than or equal to, it's an or statement. So you would do actually the same kind of a statement. I would still add on, and I did the same thing. That needs to be greater. I would still add on the negative 5. I would still put the sign going in the same direction, the variable, but this time I have to split it. So there's 2 variables. So if it's greater, it becomes an or statement, and this time I would say that negative 5 is greater than x, or x is greater than 5. Or if I write it in order, x is less than -5 or x is greater than 5. So your or statement's going to have the arrows pointing out. If this is -5 and this is +5, you want it to be less than -5 or greater than +5. And again, you can always plug numbers in from your range to check. So if I plug in -6, absolute value of -6 is 6, that's greater than 5. If I plug in +6, absolute value is 6, which is greater than 5. So just looking at like 63, that's read as absolute value of x minus 20 is less than or equal to 6. Is that an and or an or statement? And. How about 67? Or, okay, 71 you can't determine until there's just the absolute value on this side. So the first thing you want to do is divide by 2 on both sides and then determine if it's and or. This time it would stay the same, but if this was a -2 on front and I divided by -2, what happens to my inequality sign? Changes direction, which would then make it a less than statement instead of a greater. Does that make sense? So you can't determine if it's and or until the absolute value is on the side by itself.
So 71 is and or?
71 after you divide by 2 stays greater than, so it's an or. But if that was a -2, then it would go to greater. I mean, it would go to less than, and it would be an and statement.
Those two might like.
Yeah. Any questions? Any other questions on the absolute value ones? Okay, and then the quadratic inequalities. So these are the ones where if it is a quadratic, so you see like x squared, you have to do test points. So you're going to solve it as though it was an equal sign. So if I look at, let's say, something like 108, I would say x squared. I'm going to solve it as though it's equals 16, which means when I square root both sides, what do I get? Not just 4, plus or minus 4, good. So that means I have 2 answers. I would set up a number line with both of those answers on it. And then I would test points. I'm going to test a point from less than -4, like -5. -5 squared, I need to be less than or equal to 16. Is 25 less than or equal to 16? Nope, so I rule that section out. Then I would plug in something in between -4, God bless you, and 4. Make it easy on yourself like 0. Is 0 squared less than or equal to 16? Yep, this section works, which means usually it's every other. So when I plug in 5, I expect it not to work. 5 squared less than or equal to 16. 25 is not less than or equal to 16, so that does not work. So then my correct range is that middle range, and because my initial problem says less than or equal to, they get brackets. So my answer would be -4 is less than or equal to x, which is less than or equal to +4. Emily?
Like 107 where there's no like equal sign, where it's just.
You put, that just means there's parentheses instead of brackets. So everything is exactly the same. You just put parentheses instead of brackets if it's not or equal to. For something like 109, obviously you would square root both sides of your equation. You're going to do plus and minus, and then you'll subtract 2. You still get 2 answers. You still want to plug and check from the ranges. And then something like 111, you actually have to factor this. So you want to get the 9 on the side with the 4, and then factor it out. So I'll show you that like 112 because that's similar. X squared minus 6x plus 9 is less than 16. So in order to factor it to solve it, I got to get it equal to 0. I'm going to subtract the 16. I get x squared minus 6x minus 7 is less than or equal to 0. Or not less than or equal to, just less than 0. So then I would factor this out, x minus 7x plus 1. And I'm going to solve it as though it's equals and test points. So x would equal 7, x would equal -1. And then on my number line, I would do -1, 7. I'm going to plug in points left of -1 into either this original statement or into it after we subtracted the 16. It doesn't matter where you plug it in. You plug it into, again, the first one, the initial statement, or after you've subtracted the 16, it doesn't matter. So if I plug in -2, I get 4 plus 12 minus 7, 16 minus 7, which all I need it to be is less than 0. That's not going to be less than 0, so I rule that section out. Then I plug in something between negative 1 and 7. Again, if 0 is in the range, use it because it's easier. This is going to get negative 7 is less than 0, and that is true. And then I would plug in and assume that anything bigger than it, it's not going to work. So 8 squared minus 6 times 8 minus 7, 64 minus 48 minus 7. That's 9. That is not less than 0. So I know it's the middle section. And I know this time it's not an or equal. It's just less than. So I get the parentheses, and I would rewrite that as negative 1 is less than x, which is less than 7. Questions on quadratics. And if it wasn't factorable, what do you have to do? Quadratic equation, just like you used in the last section. All right, so you're going to work on those problems. There's not a lot. You're going to work on those problems, and then you're going to submit it. I'll publish that assignment now. You're going to submit it to the P.2 section.